Hello, this is Bill again. Welcome to Module 5, Designing for Ideal Light Transmission. But before we do that, we'll just recap what we discussed in previous Module 4. We demonstrated how fabricated plastic faces evolved to maximize the internal illumination. Module 5, in Module 5, we are going to emphasize how acrylic was refined even more and was able to incorporate pigmented plastic in a variety of shapes and transformations using thermoforming techniques, all with the idea of minimizing seams and so on. But a brief fast forward here to show you what happens when you have a mastery of the materials and the knowledge of how things are made, that you can in any situation come up with a solution that is even better than what you expected. This is 2003. This letter is part of the rebranding of the Royal Bank, the RBC Financial Group. It was a program that I helped. I was part of the rebrand committee at the Royal Bank. And it was going to be essentially an entirely fascia program made out of flex, continuous, wraparound, that type of thing. And we reduced the profile, and so we'll discuss that later on. But what happened, and something that was not anticipated by the future brands, the branding people out of New York who designed this program, was that the lengthened name would not accommodate certain restrictions. Namely, landlords and towns that did not like fascia signs, backlit fascia signs, they insisted on individual letters. That immediately put them in a terrible quandary. The letters were suddenly much smaller than was able to be produced with neon. Neon, because of what I previously mentioned, was a concern for induction. You had to have a minimum width for the channels and a depth of 5 inches and so on. So it was virtually impossible to make small little 5, like the one that you see, 5.5-inch channel letter. So we had to come up with a solution, and obviously it was LED. The problem with LEDs in 2003, they had a binning issue. The best binning that anybody could provide was with the new Nichia, or the people that designed or created the white LED out of blue, was 6. 1 in 6 was the correct color temperature. So what do? Bank was insistent that we had to match that yellow. We worked so hard in the working committees to match in the backlight versions, so that what we decided, we went to an OEM and developed a little pastille that held 6 LEDs. And they were very costly, but we had no choice. Now, once we resolved how to get that color out of these LEDs with these pastilles that would be mounted on the inside of the channel, we had to reduce the depth of the channel in order to be able to fabricate it and make it. So that depth was 3 3/4 inches. Now, you can't make it out of trim cap, because the architects would have had an apoplectic fit if they saw what trim cap would do to the contours of the letters. Much too tight, much too rounded. It had to be crisp. So here again, knowledge of your materials, what you can and can't do, came into play. We used 3/8 thick plastic, clear, and we surface mounted the vinyl. We had this plastic beveled and it fit 1/4-inch perimeter engagement throughout and attached to the side. It worked like a charm. The program rolled out wherever we had channel letters that were required. We were able to use that concept. That later on became, we were able to use this in other programs and devised programs with completely trimless letter. If you see a trimless letter now, it probably had its genesis from the Royal Bank program. Now back to the old days. We are going to do a brief recap of what we discussed in the previous sessions to demonstrate what the last days of sheet metal and the gradual integration of extruded aluminum that allowed hinging of these faces, the refinement of all the components inside. This is what we call the last gasp. because ultimately, with volume production and almost making it mandatory to use aluminum, the sheet metal shops and the sheet metal infrastructure to produce them virtually disappeared and was replaced with aluminum components. And it was all with the idea of assuring proper illumination of plastics. And this small little sign here was saved from the wrecker, is probably the last vestige of the old method of making sign cabinetry with sheet metal retainers with clear cast acrylic. In this case, with incandescent lamp, and this customer was way out of his time. He also made it a little tiny showcase, changing boots every once in a while. Phase retention techniques, again, subservient to the internal illumination system. They went through a gradual improvement and refinement of the method for retaining suspension strip in the plastic till the one at the far right was an actual fact made out of hollow sections of aluminum, extruded aluminum, cut diagonally to make a perfect retention retainer. Here is an example of how a sign was made using corrugated plastics with applied fabricated letters, cutout letters in both wired and solvent welded. And you see a bit of a cutaway section. I drew that to show you that the details were different for, top, bottom, and sides when you're working with corrugated, and that they were wired together. Those configurations were the ones available for the type of corrugation. The most common one used way up until the 70s was the one that you could use redographs. You've seen redographs made that also on marquees. These are the fastening methods, incorporating nichrome wire or stainless steel wire, solvent weld with the hypodermic needle, and then there's the keyhole mounts. And on pigmented plastics with white letters, we would be routing it and solvent welding it. This one is perhaps the one of the best examples of where the corrugation and to maximize the impact of the illumination, we, instead of fluorescent illumination, in this case used argon tubing, 12 feet in length. These are all 12-foot lengths of 15-millimeter argon tubing, positioned right behind the corrugation, and the letters were fabricated out of stainless steel with white faces. Naturally, the illumination had to be strong enough to be able to illuminate the background uniformly and also to assure the illumination of the letters. Here is the prime example of a typical vertically mounted fluorescent lamps illuminating modular panels across the full breadth of the 23 feet. And to maximize the illumination, taking into account that you had structural members that would go right through diagonally on to hold the arch together. And again, this is another example of what the concern of that time to avoid spray painting, and with a low cost of pigmented materials, relatively low cost of pigmented material, it was custom flanged or strip heated to integrate, interlock, assure rigidity, strength, and color fidelity. These were the typical interlocking channels. Most of them were 18 inches in center to centers, and you had the basic types. Either the C channel, the originals were made with the C channels, with requiring a tube at the end to support it with neoprene pads. The 18-inch interlocking channels were judged at one point to be sufficiently strong that they no longer needed that vertical support. It was easy to support it top and bottom, and it worked extremely well, and it had evolved into many different textures. This is the workhorse for making modular panels. They were They were easy to make. They were used either nichrome wires, nichrome heating, or there was another term for this strip, the coil strips, similar to what you'd find in your typical oven. They were easy to make, easy to process, and they were generally the workhorse in any sign shops for also making returns for interlocking faces. This is one of the classic methods for making the C-channel modular panels. It was as you can tell, it's a drop leaf table. That was the name for it. We would heat the acrylic in an overhead oven, position it, clamp it, and drop it. One of the great things about cast plexiglass or acrylic is that it was quite forgiving. You had almost a minute to set up your heated plastic, correctly heated plastic, and work with it. And if you missed, you could put it back in the oven. Once it was finished and formed, it was put into a forming cooling box. And the idea behind it was, of course, the shrinkage and the fact that as a memory plastic, it had a tendency to want to get back to its original shape. This allowed it to stay firm and crisp. Here's an example of how you could at that time do a variety of shapes using thermoforming components and solvent welding or wiring together to achieve a specific look. The ball itself was made into segments, not unlike that of an orange peel. These were orange peel sections that would be solvent welded on the inside into two halves. We experimented in some cases of blow forming, two halves, and that's probably what you see here is two halves joined together with one seam that was hidden from you. Go ahead. Again, strip heaters, they were indispensable in a sign shop because they not only covered fascias for interlocking, but also for large plastic covered letters where we could interlock and assure that the infiltration and solidifying the panel against the wind loads, and for making cube signs. Here's an example where blue is probably the toughest of all the acrylic shades. This Pepsi sign was a landmark. It's high, something like 75 feet up in the air, 72 feet in the air. And in this case, you do see a little bit of the seam, but once illuminated, it virtually disappears. Blues and greens were usually the toughest to try to dissimulate, but nevertheless, they were a necessary part of making large surface signs. Illumination of back sprayed or second surface spray painted faces was always a challenge, and the blue and the green were perhaps the worst. If this were a color picture, you would see the unevenness of the blue. It took us 5 or 6 attempts before the customer finally agreed to the kind of blue that would match the Belvedere cigarette package. This was achieved to his satisfaction, but the people in the shop had a chance, they would keep at it until they'd get it right. But blue and green was a challenge. Those are fabricated cigarettes, thermoformed cigarettes themselves. The actual filter tips were spray painted on the outside to simulate the filter. That gentleman was indirectly illuminated, and there was a steam machine behind the sign that would produce these puffs of smoke. We tried to achieve at that time to get them to puff circles like the camel in New York, but never quite made it. In any event, it was a smoker. This is perhaps, you will never see a sign like this again. Sam's Cafe. Everything that you see on that sign was made from pigmented material, including the details on that eagle. These are actual parts of blue, pigmented blue and red and yellow and green that were incorporated into that eagle logo. Everything was routed, cemented on the perimeter, and superimposed. Service was necessarily from the sides, and if you had to remove this face, you had to remove it very, very carefully for servicing. This was a high-end, sophisticated sign, and when illuminated, it really popped at you because the colors were pure. This is excess, love of plastics in excess, and naturally would have to be with a used car salesman. They're the most ostentatious, and it shows. And here again, illuminating pigmented plastics, the yellows, the reds, and so on, not a problem. But once you hit the blues or the mauves and greens, it couldn't match the daylight look, the ambient look. It was just too difficult. You would try by diffusing it on the inside and so on, but nevertheless, illuminated, it was considered an illuminated entity, and that's all it was. Here we go with eventually we had to get rid of the corrugation. The corrugation ended up looking a little too cheap, so that, but we still wanted to rigidize the face because we didn't want it to warp and give it strength. So we would actually put it on a corrugated wooden mold, and we would superimpose the letters, slap them on, and just with a typical vacuum table, not pressed at all, we would create that ridged background to give it strength. There's another example. We don't see it as clearly, but those are actual shingles made with real cedar shingles that picked up the detailing of this as best as it could. Again, the cutout of Vernon Village at the top was superimposed over these shingles and thermoformed and spray painted on the inside, on the second surface. Had it been on the first surface, it would probably look more like shingles, but it was also the idea that you had to protect the colors. This is one of my favorite projects. When I was a youngster working as a designer, I loved working on that because we had fun making it. We wanted a crushed ice look so that the Pepsi logo rested on a bed of ice. And what you see is a cross section of how we did it. We had a hardwood perimeter, and we used the garden variety crushed marble. We washed it thoroughly, put it on a bed. We had the cutout letters that were plug assisted. Plug assisted is a flat iron mold assist that would cover the perimeter of the letter to assure that it would get the definition that we were looking for. And that sign's been along for a long, long time. The last one was unfortunately destroyed just about a few months ago when the Concordia group, the Concordia University team that was doing a documentary, rushed out there, but not in time to save it. The store was sold and the sign was demolished. So at the end of an era. Here's another example of the challenges of illuminating color. This is pigmented. Again, this is a rotating sign. One side is blue, the other side is green. They had to pick the two worst colors to try to reproduce, but proper illumination, at least no shadowing, it worked well. Here's an example of the modular system. When it's pushed into a miter, these are miter channels. When into a concave version like that, even helps to simulate it even more. More of a challenge, but it was easily done. Here's another example of how the internal illumination had to accommodate the necessary reinforcing of the joint detail, the seamless look. At all times, everything you did in a sign, we try to dissimulate the mechanical joints. And this sign, when illuminated, looked like it was made out of one piece of acrylic. This is actually the first look and the first thermoformed shell sign. It was made around 1949, my understanding. I wasn't there. I was 5 years old. It was originally designed to hold, to be illuminated by incandescent lamps, and subsequently changed into fluorescence. The ability to give sharp, clear, crisp detailing attracted a lot of architects into incorporating signage into a fascia and illuminating them. This was very common. More often non-illuminated, but this is one of the more successful illuminated fascias. And this carried on, of course, into major programs. Hess was a major oil company in the U.S., and this is one of the more successful architectural illuminated. This is the pre-canopy days where you had pump island canopies, and the focal point was usually the office or the cash register area. This demonstrates Saint Hubert wanted, this was part of their new look standalone restaurants. They all had, there were about 25 in total and 30, and they actually had opened 2 of them in the Fort Lauderdale area. Saint Hubert wanted a 4-sided sign, and actually 4-sided sign with fluorescence would have been a real challenge. So we used mercury vapor. Out of mercury vapor, we were able to cover all 4 sides evenly, and we had good light bounce. But necessarily, with the rigid face, we had to have tiebacks. In this particular area, I think we had 6 tiebacks with sag rods that would assure that the face remained as firm and solid as possible. We were able to get oversized panels at that time. Those tiebacks were optically shaped so that light could be dispersed and to minimize as much as possible the actual round effect that it would have. When illuminated, you had to focus on it because you knew it was there to really see it. It was a very successful way of doing it. Les Galeries Lachine that you see on the side was a new plastic, one of the first attempts at Roman Haas to come up with an impact modified acrylic. They called it the Plexiglass 70. And that represented a challenge because these are 10 by 10 faces, and in order to be able to open them without twisting, we had put tiebacks, and those tiebacks had to be attached to tie rods, as you see in that picture. Those rods would be connected to a retainer, not the box, of course, so that when you open the face stayed stable and in one piece. This shows you quickly. We'll be going back to this picture to discuss thermoforming and the types of molds, but this gives you a quick idea that how quickly this thing was done. The crisp, clear properties of cast acrylic put on the mold and brought out after 2 or 3 minutes after cooling, and then it was spray painting. Spray painting was a real art. Especially if you did programs. You said programs, you wanted consistency, you wanted uniformity. We had special recipes for the paints, and we actually, you might call it even choreography of how you spray painted that blue so that you would avoid any blotchiness or unevenness. And it took a good practice, and of course speed was of the essence. So a recipe and a motion. The recipes would actually, if in the event that you didn't use the same painter, the same painter was actually given the strokes and the sweep of the spray painting process. Of course, illumination, testing, and then fitting and shipping. Thank you. Looking forward to Module 6.